Hello everybody watching this video. This is the second half of the notes for section 1.4. We're doing lines, which is an easy little thing to do. Here is the homework assignment for that. If you have not written it down, please do so. Hurry. Okay? Page 40, 1, 2, 4 through 52 by 4s. I will never start you on a number that's not divisible by 4 if I make you do 4s. So if you get all the way through, like halfway through, and you're on like number 38. 38 is not divisible by 4, so you got off. Does that make sense? Okay, so there is quite a few problems, but these are pretty simple to do, all right? So linear functions, we talked about slope, rise over run, y2 minus y1, x2 minus x1, all that good stuff. Let's go down to this part. There is a connection between arithmetic sequences and lines. We've already kind of talked about that, right? A linear function, y equals mx plus b, arithmetic sequences, all that good stuff, okay? Example 4, sketch the graph and confirm your sketch with a graphing calculator. Okay, we're probably going to skip that part. We're just going to sketch it because it's just easy to sketch. But I can't sketch it the way that it is right now.
Add over 5 by 2.
Okay, I'm going to solve for y. So add the 5x. So 2y equals 5x plus 2. And then divide by 2.
Y equals 5 over 2x plus 1.
Plus 1. Now, don't reduce that 5 over 2 to 2.5, right? Because it's a slope, and we want it to be listed as a fraction, right? Okay, so 5 over 2x plus 1. So that means I start at 1, and I go up 5. 1, 2, 3, 4, 5, and over 2. Or I go down 5, and to the left 2. And then I draw my line, okay? Now, you guys know we did this like on one of the first days of school, how to graph that with, you have one. It's from yesterday.
He wasn't here.
You weren't here?
Silly.
We're on the second half. You guys know how to graph that with your graphing calculator, right? You go to the y equals button and you go 5 over 2x plus 1 in your y1, right? Maybe? Sure. Okay. We'll review that later, but we're not going to do it right now. We can just graph that with our pencil and paper and move on. Okay? Good? All right, example 5, linear depreciation. That means we're going down in value. Down in value. We have an office buys a new computer system for $7,000 and 5 years later its value is $800. That is called the residual or the salvage value if you're in accounting. That's what it is. So over the course of 5 years, how much is it depreciating in value?
1240.
What? Wait. Oh, overall total.
Oh, I'm sorry.
$6,200, right? It's going from $7,000 to $800. $6,200 in the matter of 5 years, and if you divide that, it is $1,240. So that means it's going down $1,240 per year. Does that make sense? Okay. We just did. No, we're gonna do this today in calc.
What?
This is today in calc. We're doing like this exact stuff. Here you go. Okay. Write the equation that represents the value as a function of years. So I'm going to write in starting with y equals, okay? And the overall total value to begin with is 7,000. And then from there, we're decreasing 1240 each year, which is kind of like the slope, right? Per year. Okay, x is the number of years. And then there's one more thing that I need to add to that formula, which is what?
Over 1. Or under 1.
The y-intercept is 7,000. He's done. I need a negative. The 1240 is a decrease, right? So make sure that when you're doing that, your slope is going down, which means negative, okay? And that's how that works, okay? Find its value 2 years after it has been purchased. So we're just going to plug 2 in for that. If I plug 2 in, that is negative 2480 plus 7,000, or 7,000 minus 2480, whatever that is. I don't know. 4520.
I could have done that.
Did I get it? 4520? Yeah? That's how much it is after 2 years. Okay, graph the equation. I'm just going to do a little rough sketch over here, graph the equation. But I'm going to do this. Graph the equation. I'm just going to do that because we're not going to have negative values, okay? 7,000 is going to be up here. And we're going down, and I'm just going to write it like that. That's my slope. What am I going to end up dollar-wise over here on the x-axis?
Approximately
at some point it will be 800 because that's our residual value. So at a time of like on 0, it will be that much. Does that make sense? Yeah. Okay.
Next example.
Actually, nope, that is incorrect. It should go like this and stop there at 800, and this coordinate right here should be 5 years, right?
Sure.
That makes more sense, right? It's not going to drop off at 0. Yeah.
No, it wouldn't.
If your car does not run, it's worth $0.
Well, I know, but we are not even considering past 5 years. So we're just, I mean, if you then decide to keep it past the 5 years, it will continue to depreciate in value until it gets to 0. But they're not doing that. So, right? Sure. Sure.
That's not true, Hubble.
I do. Okay, we better go fast. Here we go. Point slope form. We're not going to talk about point slope form because I don't like it. If your homework assignment has point slope form, point slope form. If your homework assignment asks for point slope form, do slope intercept form instead. Okay, any standardized testing or ACT or anything else is going to do slope intercept form and not point slope form, so I don't even bother teaching it because it's going to do that, okay? So we're not going to do point slope form, we do slope intercept form instead, so change those instructions if they say that on the homework assignment, okay? Change those instructions, all right? Good? Okay, let's go to example 6 and sketch the graph of the equation of the line that passes through the point 1, -6 with a slope of 2. So we're going to start at 1, -6, 2, 4, 6, and it's going to have a slope of 2. That means up 2 over 1, 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 etc., right? And we draw our line, and that's what he looks like. Okay? All right, write the equation in slope-intercept form. I don't know why they say point slope form and then they say slope-intercept form. We're going to do slope-intercept form anyway. Y equals mx plus b. Okay, what is the m going to be? 2. What's the b going to be?
-8.
No, it's not -6.
-8.
It was 1 -6 was this coordinate, but if I go down 2 and over 1 again, where is it going to touch the y-axis? -8. So y equals 2x minus 8 is our slope-intercept form of that line. Does that make sense?
Yep.
Yeah? Okay, good to go?
Yep.
All right, moving on. We have vertical lines and horizontal lines, and vertical lines are going to go straight up and down. So like they are saying graph the line. This is a horizontal line. I don't know, we're backwards. Anyway, y equals 3. I go to 3 on the y-axis, 1, 2, 3, and put a dot. And when we have y equals 3, that's just going to be a horizontal line straight across. Like y is always going to be 3 all the way across. Okay? This is a horizontal line. He has a slope of 0, right? He has 0 slope. He's not going up or down at all. He's just staying consistently at 0. Okay? That is a horizontal line. So these are kind of crisscrossed here. Then we have vertical lines, which have undefined slope. Do you remember why it's undefined?
If you were to go,
It's not a function to begin with. It doesn't pass the vertical line test, right? So it's undefined. It has weird things happening, okay? This is a vertical line at 2. So the equation of that will be x equals 2. Now people get confused by this because vertical lines go up and down, right? But so does the y-axis, right? The y-axis goes up and down. So a lot of people say that's y equals 2 because the y-axis goes up and down. No, it's cutting through the x-axis. So that is the line x equals 2. Does that make sense? Okay? But people get those crisscross all the time because y-axis up and down, it should be y equals 2, but it's not. It's cutting through the x, okay? So find the equation of the vertical line. X equals 2, that is all. He has undefined slope. Also slope equals undefined. Okay? There you go. Happy with that?
Yep.
So
all right.
One thing,
Yes.
On one of the questions, it asks to find the equation of a line, but so the x-axis is the same on both of the points. So it would
Yes.
be, 'cause
So
you
it would
can't
be
divide
x
by
equals
0.
whatever that number is. Yes,
'Cause
correct.
You subtract the two numbers because they're the same. And with 0, you can't divide by 0.
Yes, right. So it would be x equals whatever that number is. That's the same. Yeah. Don't listen to Luke. Don't listen to Luke. He's confusing us. Okay. Parallel versus perpendicular lines. Circle the word parallel. If two lines are parallel, they have the Same slope. If two lines are perpendicular, they have a slope that is negative reciprocal, okay? So negative reciprocal, like if I have 2/3, the negative reciprocal of that would be negative 3/2. What if it's like negative 7?
1/7.
Positive 1/7 would be my slope. Does that make sense? Those are examples of that. Okay, so they're wanting us to do a parallel and a perpendicular line, so we're going to do parallel over here. And we're going to do perpendicular over here. And hope my computer doesn't die. Okay, here we go. Parallel, perpendicular. Now, here's the deal. They give us the equation to start with, and then they give us the point that it wants to go through. Okay? The equation that we have to start with, I don't know the slope of that. So the very first thing that I need to do is figure out what its slope is, or in other words, solve for y, right? So how would you like to solve for y?
Add O2y.
Yeah, so the y is negative. You can move everything to the other side, but I'm going to bump the 2y over here, right? Because that's going to make him positive. And then everything else will stay on the one side. So 3x plus 6 equals 2y, yeah? And then divide by 2, divide by 2, divide by 2. Okay, y equals 3/2x plus 3. Okay, that is what the original equation is. What is the slope of the original? 3/2. Okay, now this 3 right here, we've talked about him before in other classes. What do you do with him?
Toss him.
You toss him. You cross him off because he means nothing to me anymore, right? My new equations are going to have different b values, okay? So m equals 3/2. That is my slope, and if it's parallel, I want it to have the same slope. So I want it to literally be 3/2 and go through the point 2, -1, because that's the point that they give me, right? For perpendicular, I want the slope to be -2/3 and also go through the point 2, -1, okay? So that's the information that I need. Now I'm just building two equations, right? Okay, so here I have y equals m, which is 3/2, x plus b, and we have to find b, right? How do we find b?
You just plug in the two.
Plug in the numbers. So 2 goes in for x, don't forget that that goes there, and -1 goes in for y, okay? What is 3/2 times 2? This is like 2/1 if you need to. It'd be 6/2, which is 3, okay? And then I'm going to subtract the 3 to the other side, so the b value will be -4. B is -4, okay? But I'm not done. Let's finish writing them out. Y equals 3/2x minus 4. That is my parallel line. Happy with that? Not too bad? Okay, we're going to do the same thing for the other one. Y equals -2/3 x plus b, and we need to find the b. Okay, so again, 2 goes in for x and -1 goes in for y. Okay, this is like 2/1. This is a little bit more confusing. -2/3 times 2/1 is -4/3, right? Okay, and then I'm going to add 4/3 to the other side, plus 4/3, okay? So what's 4/3 minus 1, or -1 plus 4/3? Like 1 is the same thing as 3/3, right? So I have 4/3 minus 3/3, which is 1/3, right? Is that what you said before? 1/3 equals b, okay? So to write out the final, y equals -2/3 x plus 1/3. There we go. That's my perpendicular line. That's my parallel line. Okay? Happy with that?
No.
No?
It's -2/3 times 2, wouldn't that make it positive, and then you subtract that, which would be negative?
No, because it's negative times a positive 2.
Negative
Right?
and positive is still negative.
Negative 2/3 times a positive 2 is a -4/3. Yeah? And then you add it over. Okay? Happy with that? All right. Again, homework assignment is this guy up at the top here. There's quite a few problems, but they're really short and sweet and really quick. So there you go. Goodbye, people watching the video.